Hi, this video is going to discuss current, power, and voltage. By the end of this, students will be able to recite the equations and properties of current electricity. We've already talked about static electricity. Static meaning it's not moving, it's stationary. Charge just builds up and stays there. Current electricity, however, is concerned with flowing charge or moving electrons. In fact, the definition of current is the rate at which charge flows through a conductor. Remember, conductors are materials that allow the flow of charge. The equation that relates current, charge, and time is I equals Q over T, where the I means current for some reason. It's measured in amperes, which is designated as A as the unit, and usually it's just called amps. The Q stands for charge, measured in coulombs, like it has in Coulomb's law and the electric field strength equations, and T is time measured in seconds, as it has been in every equation that we've used time in so far. Power and voltage are topics discussed in current electricity. Voltage is a quantitative measure of the potential difference between 2 points and is measured in volts. Its symbol is V. Everything's V, that's easy. Named after a guy named Volta. The higher the voltage, the higher the electrical power. Power is measured in watts, just like it was when we talked about mechanical power, and it's related to the amount of electrical energy in a circuit. The symbol for power is P. So the equation that relates these is P equals IV. Power equals current times voltage. So if the amount of charge flowing through a conductor increases, what happens to the current? You might say the current increases, which would be correct. The equation power equals current times voltage means that if I, the current, increases, then so would the amount of charge flowing through it. Well, it's I equals Q over T specifically. Electrical energy use, the equation we're going to use for that is E equals PT, where E stands for electrical energy measured in kilowatt hours. That's a weird unit. P stands for power measured in watts, and time, this time not seconds, it's in hours. This is the only equation in this whole class that time is not in seconds, it's in hours. So as an example, to determine the monetary cost of using electrical energy, simply multiply the number of kilowatt hours used by the rate that the electric company, that around Baltimore is BG&E, charges per kilowatt hour. For example, if I use 87 kilowatt hours of electrical energy and BG&E charges 10 cents per kilowatt hour, then the total cost would just be 87 kilowatt hours times 10 cents per kilowatt hour, $8.70. That's it for this one. Thanks for watching. Make sure to take your notes use your notes to help answer the questions in Schoology and bring them to class next time.